flexible budgets, standard costs, and variance analysis. Welcome to the control tower. Welcome to class. Around here, we don't just study accounting, we do accounting. The numbers tell a story, and every variance, every standard, every flexible budget is part of that narrative. Our goal today isn't just to memorize formulas, it's to understand the why behind the why, because when you see the meaning behind the math, that's when accounting comes alive. By the end of this session, you'll think, analyze, and see like a professional, and I'll be dropping gems the whole way. Today we're diving into one of the most powerful tools in managerial accounting, variance analysis. This is where budgeting meets reality, where plans meet performance, where expectations collide with actual results. And here's what makes this beautiful. Variance analysis doesn't just tell you what went wrong or right, it tells you where to look, who to ask, and what to fix. This is the diagnostic engine of management control. If financial accounting is about telling the story of what happened, managerial accounting is about understanding why it happened and what to do next. That's the distinction that separates bookkeepers from business leaders. In the next hour, we're going to master flexible budgets, decode standard costs, and break down variances for materials, labor, and overhead. We'll see why companies like Microsoft and Meta use these tools to manage billions in operational spend, why Netflix monitors variances in content production costs, and why understanding this framework makes you indispensable in any finance or operations role. You're about to gain X-ray vision into business performance. Let's get it. The foundation. What is variance analysis? Let's start with the fundamental question. What exactly is variance analysis? At its core, variance analysis is the process of comparing actual results to budgeted expectations, then investigating the differences to understand performance. Think about it like this. You plan a road trip from Austin to Denver. You budget 8 hours of drive time, $50 in gas, and 2 meal stops. But when you actually make the trip, it takes 9.5 hours, costs $70 in gas, and you stopped 3 times because your cousin needed bathroom breaks. Variance analysis is sitting down after that trip and asking, why did we miss our targets? Was it traffic, gas prices, route choice? That analysis, that investigation, that's what turns experience into learning. In business, these variances matter exponentially more. A manufacturing company might budget $2 million for raw materials in a quarter, then spend $2.3 million. That $300,000 variance isn't just a number, it's a signal. Maybe suppliers raised prices. Maybe production used more material than expected. Maybe the purchasing manager got a better deal, but production wasted it. Each of those scenarios requires a different response, a different conversation, a different corrective action. That's why Henry Ford once said, "You can't build a reputation on what you're going to do." Variance analysis keeps you honest. It forces you to confront the gap between intention and execution. Here's the philosophical truth behind variance analysis, and this is a gem I want you to hold. Every business operates in 2 worlds simultaneously. There's the world of the plan, the budget, the forecast, the projection. And there's the world of reality, the what really happened. Variance analysis is the bridge between those 2 worlds. It's how organizations learn, adapt, and improve. Without it, you're flying blind. With it, you have a compass, a map, and a mirror. That's the why behind the why. We do variance analysis not because we love comparing numbers. We do it because it reveals truth, exposes inefficiency, and drives better decisions. That's power. The variance analysis cycle, from data to decision. Now let's talk about how variance analysis actually works in practice, because understanding the cycle is essential to making this tool useful. The variance analysis cycle follows a logical sequence that moves from measurement to action. First, you prepare performance reports comparing actual results to budgets. Second, you analyze the variances to identify which differences are significant and which are just noise. Third, you raise questions with the people responsible for those areas. Fourth, you identify root causes through investigation and dialogue. Fifth, you take corrective action based on what you learned. And sixth, you implement those changes in the next operational cycle. It's a continuous loop of measurement, analysis, learning, and improvement. Think about how Spotify uses this. They budget production costs for original podcast content, then compare actual spending to those budgets monthly. If a show comes in under budget, they investigate why. Was it efficient production? Lower talent costs? Fewer episodes? And if it's over budget, same questions, different direction. But here's the key. They don't just identify the variance and move on. They trace it back to decisions, to processes, to people. Then they adjust. Maybe they renegotiate contracts. Maybe they change production schedules. Maybe they realize their initial budget assumptions were unrealistic. That feedback loop, that's what makes companies smarter over time. As Jeff Bezos says, we are stubborn on vision, flexible on details. Variance analysis gives you the details so you can stay stubborn on the vision. The cycle also creates accountability in a healthy way. When production knows their material usage will be measured against standards, they pay attention. When purchasing knows their price variances will be reviewed, they negotiate harder. When department heads know their spending variances will be analyzed, they manage more carefully. This isn't about punishment, it's about visibility. It's about creating a culture where performance is transparent, where results are measured, and where everyone has the information they need to do better work. That's the strategic why. Variance analysis isn't just accounting, it's organizational learning made systematic. Now that we understand the cycle and purpose, let's dig into the mechanics, starting with the difference between planning budgets and flexible budgets. Planning budgets, the static snapshot. A planning budget is exactly what it sounds like. A budget prepared at the beginning of a period based on a single planned level of activity. Let's say you manage a coffee shop and you expect to serve 1,000 customers next month. You build your budget around that number. You plan for ingredients to make 1,000 drinks, labor hours to serve 1,000 customers, supplies for 1,000 transactions. Everything is calibrated to that one activity level. That's your planning budget, your static budget, your baseline projection of what should happen if reality matches expectations. Here's where it gets tricky. What happens when reality doesn't cooperate? What if you actually serve 1,200 customers instead of 1,000? On the surface, that looks like good news. You're busier, you're generating more revenue. But when you compare your actual costs to your original planning budget, things look messy. Your ingredient costs are higher than budgeted, your labor costs are higher, your supply costs are up. If you just compare actual results to the static planning budget, you might think you have a cost control problem. But do you? Or did you just serve more customers than planned, which naturally requires more resources? That's the fundamental limitation of planning budgets. They're useful for setting initial expectations, but they become misleading for performance evaluation when actual activity differs from planned activity. Here's the analogy. Imagine your cellular plan gives you 10 gigabytes of data per month. You budget your usage around that. But then you travel for work and use 15 gigabytes because you're streaming meetings all day. Your bill is higher. Is that a problem? Not really, you just used more of the service. Comparing your actual bill to your 10 gigabyte plan tells you nothing about whether you managed your usage efficiently. You need a flex to the new reality. Same logic applies in business. Comparing actual costs at 1,200 units of activity to a budget built for 1,000 units is comparing apples to oranges. It distorts the analysis and leads to bad conclusions. That's why we need flexible budgets. Now that we see the problem with static comparisons, let's see how flexible budgets solve it. Flexible budgets, the dynamic solution. A flexible budget adjusts for the actual level of activity that occurred, allowing you to make valid comparisons between what costs should have been and what costs actually were. This is the solution to the apples to oranges problem. Instead of comparing actual results to a plan that assumed a different activity level, you recalculate the budget based on the activity level that actually happened. Now you're comparing apples to apples. You're isolating cost control performance from volume effects. This is where clarity begins. Let's go back to the coffee shop example. You planned for 1,000 customers, but served 1,200. Instead of stubbornly comparing your actual costs to the original 1,000 customer budget, you flex the budget. You ask, if I had known I was going to serve 1,200 customers, what should my costs have been? For variable costs like coffee beans, milk, cups, those scale proportionally. If 1,000 customers required $500 in beans, 1,200 customers should require $600. That $600 becomes your flexible budget for beans. Now, when you compare actual bean costs to that flexible budget amount, you're seeing whether you controlled costs well at the activity level you actually experienced. That's the power of the flex. Here's a gem for you. Flexible budgets reveal the truth that planning budgets obscure. They separate two fundamentally different questions. Question 1. Did we hit our activity target? That's a sales and operations question. Question 2. Did we control our costs efficiently at the activity level we achieved? That's a management and process question. Planning budgets conflate those questions. Flexible budgets separate them. And that separation is everything. It's the difference between blaming a manager for high costs that were actually driven by high volume versus identifying genuine inefficiency. Companies like Toyota built their legendary production system partly on this insight. Flexible analysis of performance adjusted for actual conditions. When you understand how to flex a budget, you understand how to see clearly. That clarity transforms your ability to manage. Now let's see this in action with a concrete example. Larry's lawn service, the planning budget problem. Let me introduce you to Larry. Larry runs a lawn service company, basic business model. He mows lawns, charges per lawn, tracks his costs, tries to make a profit. At the start of the month, Larry creates a planning budget. He expects to mow 500 lawns. His revenue expectation is $15,000. That's $30 per lawn. His costs break down like this. Gas for the mowers is variable, $10 per lawn. Labor is also variable, $5 per lawn. Depreciation on his equipment is fixed, $1,200. Insurance is fixed, $800. Adding it up, total expected costs are $9,500. That leaves him with a planned profit of $5,500. That's his plan, his baseline, his expectation going into the month. Now the month plays out and reality hits. Larry actually mows 550 lawns. That's 50 more than planned, about 10% higher activity. His actual revenue comes in at $16,000. His actual costs: gas costs $6,000, labor costs $3,000, depreciation stayed at $1,200, insurance stayed at $800, and he had some additional administrative expenses of $200. Total actual costs, $10,200. His actual profit, $5,800. On the surface, not bad. He exceeded his planned profit by $300. But here's the question. Did Larry actually perform well? Or is that comparison misleading because he mowed more lawns than expected? If you compare his actual results to his static planning budget, you see a revenue variance of $1,000 favorable. That's great, he made more than expected. But you also see cost variances that look concerning. Gas was budgeted at $5,000 for 500 lawns, but actual was $6,000. That's a $1,000 unfavorable variance. Labor was budgeted at $2,500. Actual was $3,000. Another $500 unfavorable. Those variances make it look like Larry has cost control issues. But does he? Or did those costs go up simply because he mowed more lawns? You can't tell from a static budget comparison. That's the limitation in action. We need to flex the budget to see the truth. Let's do exactly that on the next slide. Larry's lawn service, the flexible budget reveal. Now let's flex Larry's budget to the actual activity level of 550 lawns and see what really happened. For revenue, at $30 per lawn, 550 lawns should generate $16,500. That's the flexible budget revenue. Larry's actual revenue was $16,000, so he actually has a $500 unfavorable revenue variance. He didn't charge the full $30 per lawn on average. Maybe he gave some discounts. Maybe he had some disputes. but that's a revenue performance issue worth investigating. For gas costs, at $10 per lawn variable cost, 550 lawns should cost $5,500. Larry's actual gas cost was $6,000. Now we have a clear $500 unfavorable spending variance on gas. That's a real cost control issue. Maybe gas prices went up. Maybe the mowers were inefficient. Maybe there was waste. But it's a genuine variance isolated from volume effects. For labor, at $5 per lawn, 550 lawns should cost $2,750. Actual was $3,000, so there's a $250 unfavorable variance on labor. Again, that's real. Maybe he paid overtime rates. Maybe productivity was lower than expected, but it's not explained by volume. Fixed costs, depreciation and insurance, those stay the same because they're fixed. And the $200 in administrative expenses, that's an unfavorable variance because it wasn't in the original plan at all. Here's what the flexible budget revealed. Larry's profit problems aren't about mowing more lawns. They're about revenue per lawn being slightly low and costs per lawn being slightly high. That's actionable intelligence. Now Larry knows where to focus. He needs to examine his pricing discipline, investigate why gas costs exceeded standard, and figure out why labor was above the expected rate. Without the flexible budget, he'd be celebrating the higher profit without realizing he left money on the table. With the flexible budget, he sees the opportunities. That's the difference between managing by intuition and managing by analysis. This is why flexible budgets matter. They turn confusion into clarity, noise into signal. And clarity, that's the first step to improvement. Now let's formalize how we build and use flexible budgets systematically. Building flexible budgets, the formula foundation. To build a flexible budget, you need to understand cost behavior, specifically the distinction between variable costs and fixed costs. Variable costs change in total proportionally with activity level. If you produce more units, variable costs go up proportionally. If you produce fewer units, variable costs go down proportionally. Common examples: direct materials, direct labor in many settings, sales commissions, shipping costs. Fixed costs remain constant in total, within the relevant range, regardless of activity level. Examples: rent, insurance, salaries, depreciation. The relevant range matters because at extreme levels, even fixed costs can change, but within normal operating ranges, they stay steady. The flexible budget formula for any cost is total flexible budget cost equals fixed cost component plus variable cost per unit times actual activity level. For a totally variable cost, the fixed component is 0. For a totally fixed cost, the variable component is 0. For a mixed cost, you have both components. Let's apply this. Imagine a tech support call center. They have a manager salary of $8,000 per month. That's fixed. They have hourly staff paid $20 per hour, and they expect each call to take 0.5 hours, so variable cost per call is $10. If they plan for 1,000 calls, but actually handle 1,200 calls, what's the flexible budget for total labor costs? Fixed component is $8,000, variable component is $10, times 1,200 calls, that's $12,000. Total flexible budget, $20,000. Now suppose actual labor costs were $22,000. The variance is $2,000 unfavorable. That variance is isolated from volume effects because we flex to the actual call volume. The investigation then focuses on why costs exceeded the flexed amount. Maybe calls took longer than expected, maybe overtime was required, maybe staffing levels were inefficient. But at least now we're asking the right questions. That's the power of the formula. It's simple algebra that creates profound clarity. Warren Buffett once said, "Accounting is the language of business." He's right, but more precisely, flexible budgets are the dialect of performance management. They let you speak with precision about what happened and why. Master this formula and you master the foundation of cost analysis. Now let's take this foundation and see how it helps us understand revenue and spending variances separately. Revenue and spending variances, isolating performance. Once you've flexed your budget to actual activity levels, you can calculate two critical types of variances: revenue variances and spending variances. A revenue variance compares actual revenue to flexible budget revenue. Remember, flexible budget revenue is calculated as the standard price per unit times actual units sold. If actual revenue exceeds flexible budget revenue, that's favorable. You charged more than expected per unit on average. If actual revenue is less than flexible budget revenue, that's unfavorable. You discounted or lost pricing power. A spending variance compares actual costs to flexible budget costs. If actual costs are less than flexible budget costs, that's favorable. You controlled spending well. If actual costs exceed flexible budget costs, that's unfavorable. Costs were higher than they should have been at that activity level. Here's why this separation matters. Revenue variances tell you about pricing discipline, sales mix, discounting behavior, and market conditions. Spending variances tell you about cost control, efficiency, waste, and input prices. These are fundamentally different dimensions of performance, often managed by different people. Sales teams influence revenue variances. Operations teams influence spending variances. By separating them cleanly, you create accountability and focus. You're not lumping everything into one confusing number. You're breaking performance into components that people can actually manage. Let's go back to Larry for a second. His revenue variance was $500 unfavorable because he didn't achieve $30 per lawn on average. That's a pricing or sales execution issue. Maybe he needs to reconsider his discount policy. His spending variances on gas and labor were unfavorable. Those are operational cost control issues. Maybe he needs better fuel management or scheduling. See how the analysis directs attention to specific problems? That's strategic, that's actionable. As Peter Drucker taught us, you can't manage what you don't measure. Revenue and spending variances give you the measurements that make management possible. They turn vague feelings about performance into concrete numbers that demand explanations. And once you have explanations, you can drive improvement. That's the progression from data to insight to action. Now let's add another layer of sophistication: multiple cost drivers. Multiple cost drivers when one dimension isn't enough. Most of the flexible budgets we've discussed so far use a single cost driver, usually units produced or units sold, but in real business operations, costs often depend on multiple drivers. A restaurant's costs depend on the number of meals served, but also the average complexity of those meals and the hours of operation. A logistics company's costs depend on the number of packages shipped, but also the weight and distance. A consulting firm's costs depend on the number of projects, but also the hours per project. When costs depend on multiple drivers, using just one driver in your flexible budget introduces distortion. You need a more refined approach. Let's say Larry expands his lawn service to include edging and trimming in addition to basic mowing. The edging service is charged at $30 per hour, and different customers require different amounts of time. Now Larry's costs are driven by two factors: the number of lawns mowed and the hours of edging provided. His gas costs might still be driven primarily by lawns mowed, but his labor costs are now driven by both lawns and edging hours. His flexible budget needs to reflect both drivers. For labor, the formula becomes labor cost equals fixed labor component plus variable rate per lawn times lawns mowed plus variable rate per hour times edging hours. This gives a more accurate picture of what costs should be. Here's the deeper principle. The better your cost drivers match actual cost behavior, the more accurate your flexible budgets and variance analysis become. Companies like Tesla track costs against dozens of drivers: production volume, battery capacity installed, factory utilization rates, automation versus manual labor hours. They build sophisticated, flexible budgeting models that capture the complexity of their operations. You don't need to go that complex in most settings, but you do need to recognize when a single driver is too simplistic. Multiple drivers improve explanatory power. They help you understand why costs vary, which is the whole point. And that understanding, that's what separates Adequate analysis from excellent analysis. It's the why behind the why showing up in your model design. Now let's shift gears from flexible budgets to the concept of standard costs, which is the foundation of more detailed variance analysis. Standard costs, setting the performance benchmark. Standard costs are predetermined unit costs that serve as benchmarks for measuring performance. Think of them as the should cost for producing 1 unit of product or delivering 1 unit of service. A standard cost has 2 components, a quantity standard and a price standard. The quantity standard specifies how much of an input should be used per unit of output. For example, a parka should require 0.1 kilograms of fiberfill insulation. That's the quantity standard for that material. The price standard specifies what the cost per unit of input should be. For example, fiberfill should cost $5 per kilogram. That's the price standard. Multiply quantity standard by price standard, and you get the standard cost per unit. 0.1 kilograms times $5 per kilogram equals 50 cents of fiberfill per parka. Standard costs are everywhere in business. Nike has standard cost for the leather in a pair of shoes, the labor hours to assemble them, the overhead to run the factories. Chipotle has standard costs for the amount of rice per bowl, the guacamole per side, the labor minutes per transaction. Oracle has standard costs for the support hours per software implementation. These standards become the baseline for flexible budgets and variance analysis. They answer the question, if everything goes according to plan, what should it cost? And when reality deviates from standards, variance analysis kicks in to investigate why. Setting standards requires careful work. You don't just guess, you study the production process, you gather data, you consult with engineers and experienced workers, you test and refine. For materials, you create a bill of materials, specifying exactly what goes into each unit. For labor, you conduct time and motion studies to determine realistic time requirements. For overhead, you analyze historical data and expected activity levels. The goal is standards that are tight enough to motivate efficiency, but realistic enough to be achievable. As Vince Lombardi said, perfection is not attainable, but if we chase perfection, we can catch excellence. Standards embody that philosophy. They set the target we aim for, and variance analysis tells us how close we got. Now let's break down how we use these standards to analyze material costs in detail. Materials variance framework, price and quantity separation. When you use standard costs for materials, you can decompose the total variance into 2 components, the materials price variance and the materials quantity variance. The materials price variance measures the impact of paying a different price than standard for the materials you purchased. The materials quantity variance measures the impact of using a different quantity of materials than standard for the units you produced. This separation is crucial because these 2 variances reflect different management responsibilities and different types of problems. The formula for materials price variance is actual quantity purchased times the difference between actual price per unit and standard price per unit. If you paid more than standard, the variance is unfavorable. You lost money on pricing. If you paid less than standard, the variance is favorable. You saved money on purchasing. Notice we use the quantity purchased, not the quantity used, because purchasing happens at the point of acquisition. The formula for materials quantity variance is standard price per unit times the difference between actual quantity used and standard quantity allowed. Standard quantity allowed equals standard quantity per unit times actual production volume. If you used more materials than standard for the units you produced, the variance is unfavorable. You wasted materials. If you used less, the variance is favorable. You were efficient. Here's the strategic insight. Separating price and quantity variances creates accountability without ambiguity. The purchasing manager controls the price variance. They negotiate with suppliers. They time purchases. They search for deals. The production manager controls the quantity variance. They oversee the manufacturing process. They train workers. They maintain equipment. They minimize waste. By calculating separate variances, you can have specific conversations with specific managers about specific performance dimensions. You're not just saying materials costs were over budget. You're saying we saved $300 on purchasing, but lost $800 on waste. Let's talk about production efficiency. That precision drives action. Now let's see this framework applied to a real example so the mechanics become crystal clear. Glacier Peak Outfitters, materials variance example. Let me walk you through a complete materials variance analysis using a company called Glacier Peak Outfitters. They manufacture high-quality outdoor parkas. For each parka, the standard calls for 0.1 kilograms of fiberfill insulation at a standard price of $5 per kilogram. So the standard material cost per parka is 50 cents. In a recent month, Glacier Peak produced 2,000 parkas. Under standard, they should have used 200 kilograms of fiberfill. That's 0.1 kilograms per parka times 2,000 parkas. That's the standard quantity allowed for the actual production. Now here's what actually happened. The purchasing manager bought 210 kilograms of fiberfill, paying a total of $1,029. The production team used all 210 kilograms to make the 2,000 parkas. Let's calculate the variances. First, the materials price variance. Actual quantity purchased was 210 kilograms. Actual price per kilogram was $1,029 divided by 210 kilograms. That's $4.90 per kilogram. Standard price was $5 per kilogram. Price variance equals 210 kilograms times $4.9 minus $5, which equals 210 times negative 0.1 equals negative $21. Since we paid less than standard, this is a $21 favorable variance. The purchasing manager did well, got a better price than expected. Now the materials quantity variance. Standard price is $5 per kilogram. Actual quantity used was 210 kilograms. Standard quantity allowed for 2,000 parkas was 200 kilograms. Quantity variance equals $5 times 210 minus 200, which equals $5 times 10 kilograms equals $50 unfavorable. Production used 10 more kilograms than they should have for 2,000 parkas. That's inefficiency or waste, costs us $50. Net result, we saved 21 on price, but lost 50 on quantity, for a total unfavorable variance of $29. Now, management knows exactly where to focus. They need to investigate production waste while acknowledging good purchasing. That's actionable intelligence. This level of detail transforms general awareness into specific improvement opportunities. Now let's talk about who's responsible for these variances and why that matters. Responsibility assignment, the purchasing and production dynamic. The materials price variance is typically assigned to the purchasing manager, and the materials quantity variance is typically assigned to the production manager. This assignment seems logical on the surface, but it masks a complexity that every good manager needs to understand. The purchasing manager controls when materials are bought, which suppliers are used, what quantities are ordered, and how negotiations are conducted. All of those decisions influence price. But here's the twist. Purchasing decisions can also influence quantity variances. If the purchasing manager buys cheaper, lower quality materials to generate a favorable price variance, production might experience higher waste and an unfavorable quantity variance. Quality and price are often inversely related in material procurement. Similarly, production can influence price indirectly. If production runs behind schedule or forecasts demand poorly, they might force purchasing to make rush orders at premium prices. If production damages materials through poor handling, purchasing has to buy more, potentially at unfavorable rates. The point is this: variance analysis isolates dimensions of performance, but it doesn't isolate people into silos. The best organizations recognize that purchasing and production are interdependent, that trade-offs exist, and that optimizing one variance at the expense of another is a losing strategy. The goal is total cost optimization, not sub-optimization of individual metrics. This is where leadership comes in. As a manager, you can't just hand someone a variance report and demand explanations. You need to understand the context, ask thoughtful questions, facilitate dialogue between departments, and look for systemic issues. Maybe the real problem isn't purchasing or production individually. Maybe it's a lack of communication between them about quality requirements. Maybe it's unrealistic standards that set people up to fail. Maybe it's incentive systems that reward the wrong behaviors. Steve Jobs once said, "Innovation distinguishes between a leader and a follower." I'd add that understanding the why behind variances distinguishes between a manager who enforces and a leader who elevates. Variance analysis gives you the numbers, but wisdom interprets them correctly. Now let's move from materials to labor and see how similar principles apply with different mechanics. Labor variances, rate and efficiency dimensions. Labor variances work conceptually just like materials variances, but with terminology and focus that reflects human work instead of physical inputs. The two labor variances are the labor rate variance and the labor efficiency variance. The labor rate variance measures the impact of paying a different wage rate than standard. The labor efficiency variance measures the impact of using a different number of hours than standard to produce your output. Just like with materials, this separation clarifies accountability and focuses investigation. The formula for labor rate variance is actual hours. Work times the difference between actual rate per hour and standard rate per hour. If you paid higher wages than standard, the variance is unfavorable. If you paid lower wages, the variance is favorable. The formula for labor efficiency variance is standard rate per hour times the difference between actual hours worked and standard hours allowed. Standard hours allowed equals standard hours per unit times actual production volume. If workers took more hours than standard to produce the output, the variance is unfavorable. Productivity was low. If they took fewer hours, the variance is favorable. Productivity was high. Here's what makes labor variances fascinating. They reflect not just numbers, but human performance, skill, training, motivation, and working conditions. An unfavorable labor rate variance might mean you paid overtime because production was urgent. It might mean you hired more experienced workers who command higher wages. It might mean your wage assumptions were outdated. An unfavorable labor efficiency variance might mean workers were poorly trained, or equipment was malfunctioning, or materials were difficult to work with, or supervision was inadequate, or morale was low. Labor variances are windows into the human side of operations, the side that's harder to model but ultimately more important to success. Let's see this in action with Glacier Peak again, so the calculations become second nature. Glacier Peak labor variances, working through the numbers. Back to Glacier Peak Outfitters and their parka production. The standard labor requirement is 1.2 hours per parka at a standard wage rate of $10 per hour. That makes the standard labor cost per parka $12. For 2,000 parkas produced, the standard hours allowed would be 1.2 hours times 2,000 parkas equals 2,400 standard hours. That's the baseline what labor should have taken if everything went according to plan. Here's the actual performance. The production team worked 2,500 actual hours at an actual wage rate of $10.50 per hour. Total actual labor cost was $26,250. Let's decompose this. First, the labor rate variance. Actual hours were 2,500. Actual rate was $10.50 per hour. Standard rate was $10 per hour. Labor rate variance equals 2,500 hours times $10.50 minus $10, which equals 2,500 times 50 cents equals $1,250 unfavorable. They paid 50 cents more per hour than standard on average for 2,500 hours, cost us $1,250. Now the labor efficiency variance. Standard rate is $10 per hour. Actual hours were 2,500. Standard hours allowed were 2,400. Labor efficiency variance equals $10 times 2,500 minus 2,400, which equals $10 times 100 hours, equals $1,000 unfavorable. The team took 100 more hours than standard to produce 2,000 parkas. At a standard rate of $10 per hour, that's a $1,000 efficiency loss. Both variances are unfavorable. Total labor variance is $2,250 over budget. Now management has clear targets. Figure out why wages exceeded standard. Was it overtime or pay increases? And figure out why productivity was below standard. Was it training, materials, or equipment? That specificity is power. You're not guessing about labor problems, you're pinpointing them. Now let's talk about who owns these labor variances and what drives them. Labor variance responsibility, the production manager's domain. Labor variances are typically assigned to the production manager or operations supervisor. This makes sense because production management directly influences labor deployment, scheduling, training, and supervision. The production manager decides how many workers to assign, which workers to assign, how tasks are organized, what training is provided, and how performance is monitored. All of these decisions affect both labor rate and efficiency. But let's dig deeper into each variance. The labor rate variance can arise from several sources. If the standard assumed an average wage of $10, but the actual mix of workers included more experienced employees earning $12, you get an unfavorable rate variance. That might actually be a good thing if those experienced workers are more productive. If you had to pay overtime to meet production deadlines, that creates an unfavorable rate variance. Was the overtime due to poor scheduling or due to unexpected demand surges? Context matters. If union negotiations resulted in wage increases that weren't reflected in the standards, that's a rate variance that's predictable but requires standard updates. The labor efficiency variance is even more revealing. Unfavorable efficiency can result from poor training, where workers take longer because they don't know the process well. It can result from inferior materials that are harder to work with, in which case the root cause is actually a purchasing decision that shows up as a labor variance. It can result from equipment downtime or malfunction, in which case maintenance is the real issue. It can result from inadequate supervision or low morale. The point is this: efficiency variances are symptoms, not diagnoses. The production manager owns the variance, but fixing it requires understanding the underlying cause. As W. Edwards Deming taught us, a bad system will beat a good person every time. Labor efficiency problems often point to system issues, not people issues. The variance tells you where to look, but you still have to investigate and think. Now let's extend this logic to overhead costs and see how variance analysis adapts. Variable manufacturing overhead, the third dimension. Variable manufacturing overhead includes all the manufacturing costs that vary with production activity but aren't direct materials or direct labor. Examples include indirect materials like lubricants and supplies, indirect labor like maintenance and material handling, utilities that vary with machine usage, and small tools. These costs are typically allocated to products based on a predetermined overhead rate tied to an activity measure, most commonly direct labor hours or machine hours. Just like with materials and labor, you can calculate variances for variable overhead. The two variances are the variable overhead rate variance and the variable overhead efficiency variance. The rate variance measures whether you spent more or less per hour of the activity base than the standard rate. The efficiency variance measures whether you use more or fewer hours of the activity base than standard for your production volume. The formulas mirror labor variances because the logic is identical. Variable overhead rate variance equals actual hours times the difference between actual rate and standard rate. Variable overhead efficiency variance equals standard rate times the difference between actual hours and standard hours allowed. Here's the philosophical insight. Overhead is where cost management gets fuzzy. Direct materials and direct labor are traceable and visible. Overhead is everything else, the supporting cast of costs that enable production but don't directly touch the product. Because overhead is less visible, it's also easier to let it drift. Variable overhead variances force visibility. They make you ask, did we control utility usage? Did we minimize waste on supplies? Did we schedule maintenance efficiently? Without variance analysis, overhead just becomes a pool of costs that grows over time. With variance analysis, overhead gets the same scrutiny as materials and labor. That discipline matters. Amazon doesn't just track the cost of products in their warehouses. They track the cost per square foot, the cost per pick, the overhead efficiency at every level. That's how you scale profitably. Now let's calculate some overhead variances and make this concrete. Glacier Peak. Overhead variances. Completing the picture. Let's finish Glacier Peak's variance analysis by calculating their variable manufacturing overhead variances. The standard variable overhead rate is $4 per direct labor hour. Since the standard labor time per parka is 1.2 hours, the standard variable overhead per parka is $4.8. For 2,000 parkas, the standard hours allowed are 2,400 hours, same as we calculated for labor. The flexible budget for variable overhead is $4 per hour times 2,400 hours equals $9,600. Here's what actually happened. Actual direct labor hours were 2,500, same as before. Actual variable overhead costs totaled $10,500. The actual rate per hour is 10,500 divided by 2,500 hours equals $4.20 per hour. Now let's calculate. Variable overhead rate variance equals 2,500 hours times 420 minus $4, which equals 2,500 times 20 cents, equals $500. Unfavorable. They spent 20 cents more per hour than standard on overhead, costs $500. Variable overhead efficiency variance equals $4 times 2,500 minus 2,400, which equals $4 times 100 hours, equals $400 unfavorable. Since they used 100 more labor hours than standard and variable overhead is applied based on labor hours, they incurred $400 more overhead than they should have. Both variances are unfavorable. Total variable overhead variance is $900 over budget. Notice something. The efficiency variance for overhead is driven by the same excess labor hours that created the labor efficiency variance. That's not a coincidence. When labor is inefficient, variable overhead follows because it's allocated based on labor hours. That connection reveals how inefficiencies cascade. Now we've analyzed materials, labor, and overhead variances for Glacier Peak. Let's step back and see what patterns emerge from this comprehensive view. Integrated variance analysis, seeing the whole picture. When you step back and look at all of Glacier Peak's variances together, patterns emerge that aren't visible when you look at each variance in isolation. Materials. Favorable price variance of $21, unfavorable quantity variance of $50. Labor. Unfavorable rate variance of $1,250, unfavorable efficiency variance of $1,000. Variable overhead. Unfavorable rate variance of $500, unfavorable efficiency variance of $400. Total variance, $3,179 unfavorable. That's significant money on just 2,000 units. But here's what the integrated view reveals. The biggest problems at Glacier Peak are labor-related. Both the labor rate and efficiency variances are unfavorable and substantial. And because variable overhead is tied to labor hours, the inefficiency in labor is driving overhead variances too. The $400 overhead efficiency variance is a symptom of the underlying labor efficiency problem. This suggests management should focus their investigation on the production process. Why did production take 100 more hours than standard? Why did the wage rate exceed standard by 50 cents per hour? Were they using overtime? More experienced workers? Was there training deficiency, equipment problems, material quality issues that slowed work? Here's a gem. Variance analysis is most powerful when you view it systemically, when you look for connections between variances, when you trace effects back to root causes. A single variance is a data point. Multiple variances together tell a story, and that story guides you toward meaningful action. Michael Dell said, "Ideas are commodity. Execution of them is not. Variance analysis is how you measure execution. An integrated variance analysis is how you understand execution deeply enough to improve it. That's the why behind the why. We don't do variance analysis just to calculate numbers. We do it to understand the business, to surface problems, to drive better decisions. When you see it that way, variance analysis transforms from tedious accounting to strategic intelligence. Now, let's address some timing issues that matter for accurate variance analysis. Timing considerations. when you buy versus when you use. One subtlety in variance analysis that trips people up is the timing difference between purchasing materials and using materials. The materials price variance is calculated based on the quantity of materials purchased, because that's when the price is locked in and the purchasing decision is made. The materials quantity variance is calculated based on the quantity of materials used in production, because that's when the usage decision is made and waste occurs. This timing difference is deliberate and important. Imagine a company buys 5,000 units of raw material in January at a favorable price, but only uses 4,000 units in January's production. The remaining 1,000 units sit in inventory. You calculate the price variance on all 5,000 units purchased, because the purchasing manager's performance is evaluated on the entire purchase. But you only calculate the quantity variance on the 4,000 units used in production because the production manager's performance is evaluated on actual production. If you conflated these, you'd be mixing purchasing and production responsibilities in a way that obscures accountability. This separation also has a practical benefit. You identify price variances immediately when purchases are made, not later when materials are used. That gives you timely information for decision making. If you're paying more than standard for materials, you want to know right away so you can renegotiate, find alternative suppliers, or adjust your standards if market conditions have changed permanently. You don't want to wait weeks or months until production uses those materials. Timeliness of information is a critical component of useful information. As Bill Gates says, how you gather, manage, and use information will determine whether you win or lose. Variance analysis with proper timing gives you information when it matters. Now let's synthesize everything we've learned and talk about how organizations actually use variance analysis in practice. Practical application: how real companies use this. Let's talk about how companies actually deploy variance analysis in their management systems. First, they set standards based on engineering studies, historical data, and market research. Those standards go into the budgeting system and the standard costing system. Second, they track actual results through their accounting systems, capturing actual quantities, actual prices, actual hours, actual rates. Third, they calculate variances regularly, usually monthly, comparing actual performance to flexible budgets based on actual activity levels. Fourth, they investigate significant variances, typically using a management by exception approach where only variances above a certain dollar threshold or percentage threshold get detailed investigation. Fifth, and this is crucial, they have structured review processes. Production meetings where variances are discussed, explanations are provided, and corrective actions are identified. These aren't blame sessions, they're problem-solving sessions. The goal is learning and improvement, not punishment. Sixth, they update standards periodically when production processes change, when market conditions shift, or when learning occurs. Standards aren't carved in stone, they evolve. Seventh, they link variance analysis to performance evaluation and incentive compensation, but carefully because what you measure and reward is what you get, so you better measure and reward the right things. Companies like Procter & Gamble, General Electric, and Emerson Electric are legendary for their variance analysis systems. They use them not just for cost control, but for continuous improvement. They train managers to read variance reports like doctors read diagnostic tests, looking for symptoms that point to underlying conditions. They create cultures where variance analysis is expected, routine, and valued. That's the difference between companies that just do accounting and companies that use accounting to drive operational excellence. And that difference compounds over time. Small improvements in efficiency, cost control, and decision-making add up to massive competitive advantages. That's the power of disciplined variance analysis practiced consistently. Now let's talk about the limitations of variance analysis so you understand when to use it and when to look for other tools. Limitations and cautions. What variance analysis can't do. Variance analysis is powerful, but it's not magic. It has limitations you need to understand. First, variance analysis is backward-looking. It tells you what happened, not what will happen. It's diagnostic, not predictive. You need to combine it with forward-looking tools like forecasting and scenario planning to manage proactively. Second, variance analysis depends on the quality of your standards. If your standards are outdated, too loose, or too tight, your variances will be misleading. Garbage in, garbage out. Standards require maintenance and validation. Third, variance analysis focuses on what can be quantified and measured. Some of the most important factors in business performance are qualitative: employee morale, customer satisfaction, brand reputation, innovation capability. Variance analysis doesn't capture those directly. You need other measurement systems for that. Fourth, variance analysis can create perverse incentives if implemented carelessly. If you punish managers for unfavorable variances without understanding context, they'll start gaming the system, manipulating numbers, or making suboptimal decisions just to look good on variance reports. That's why variance analysis must be paired with thoughtful management, not mechanical enforcement. Fifth, variance analysis is detail-oriented and time-consuming. Calculating variances for every cost category across every department every month takes effort. You have to decide what level of detail is worth the cost. Many companies track detailed variances for major costs but aggregate smaller costs into broader categories. It's a cost-benefit trade-off. Here's the philosophical takeaway. No single tool, not even variance analysis, gives you complete understanding of business performance. You need multiple perspectives, multiple measures, both financial and non-financial, both quantitative and qualitative. As Charlie Munger teaches, to the man with only a hammer, every problem looks like a nail. Variance analysis is one powerful tool in your management toolkit, but it's not the only tool. Use it where it adds value, supplement it where it falls short. That's the wisdom of practical application. Now let's look at some advanced applications for those who want to go deeper. Advanced topics: mix and yield variances. For those interested in going deeper, there are additional layers of variance analysis used in complex production environments. One common extension is sales mix and quantity variances, which decompose revenue variances into effects from changing the mix of products sold versus changing total sales volume. Another is labor mix and yield variances in settings where you use different types of labor with different skill levels and costs. A third is material mix and yield variances in industries like chemicals, food processing, or pharmaceuticals, where inputs can be substituted and output yields vary. Let me illustrate with a simple example. Imagine a bakery makes two products, regular bread and artisan bread. Regular bread sells for $3, artisan sells for $6. If they sell more regular bread than planned and less artisan bread, even if total units sold hit target, revenue will be below budget. A sales mix variance isolates that effect. Similarly, in a factory that can use experienced workers at $15 per hour or trainees at $10 per hour, if you use a different mix than planned, that creates a labor mix variance separate from efficiency and rate variances. These advanced variances add complexity but also add insight in the right contexts. The question is always, does the additional detail improve decisions enough to justify the extra work? In high-volume, high-margin industries, the answer is often yes. In lower volume or service settings, maybe not. As you progress in your career, you'll develop judgment about what level of analysis is appropriate for your situation. The principles we've covered today, planning budgets versus flexible budgets, price versus quantity variances, rate versus efficiency variances, those principles scale and adapt to any level of complexity. The foundation we've built here is what matters. Everything else is an extension. Now let's talk about how variance analysis fits into the broader management control system. Variance analysis in the control cycle, the feedback loop. Variance analysis is one component of the broader management control system. Let me put it in context. Management control systems have four main components. First, strategic planning, where you set long-term goals and directions. Second, budgeting, where you translate strategy into specific financial plans for the coming period. Third, execution, where you operate the business and perform activities. Fourth, performance evaluation, where you measure results, compare to plans, and take corrective action. That's the cycle. Variance analysis happens in that fourth step, performance evaluation. But here's what makes it powerful. Variance analysis creates a feedback loop that informs all the other steps. When you analyze variances, you learn about your business. You discover that certain costs are higher than expected, certain processes are less efficient than assumed, certain market conditions differ from projections. That learning feeds back into strategic planning. You adjust your strategy based on what you learned. It feeds back into budgeting. You update assumptions and standards. It feeds back into execution. You change processes and behaviors. This feedback loop is how organizations learn and adapt over time. The best companies like Toyota, Apple, and Netflix, have fast, tight feedback loops. They measure performance frequently, analyze variances quickly, identify root causes rigorously, and implement corrections rapidly. That speed of learning is a competitive weapon. Slower companies also do variance analysis, but by the time they figure out what went wrong and fix it, the market has moved, and the lesson is obsolete. Speed matters, discipline matters, and the combination of speed and discipline in your control cycles is what separates good management from great management. Ray Dalio built Bridgewater Associates on the principle of radical transparency and systematic learning from mistakes. Variance analysis, done right, embodies those same principles. Now let's pivot to real-world complexity and talk about how variance analysis adapts to service businesses, not just manufacturing. Variance analysis beyond manufacturing, services, and beyond. Everything we've discussed has used manufacturing examples, parkas, materials, labor, but variance analysis applies equally to service businesses, nonprofits, government agencies, and any organization that plans and measures performance. The concepts remain the same, the terminology and applications adapt. Let's walk through a service example to illustrate. Consider a consulting firm that bills clients based on partner hours, senior consultant hours, and junior consultant hours at different rates. They create a budget at the start of a project expecting a certain number of hours at each level. Actual delivery differs. They can calculate rate variances. Did we bill clients at the expected rates, or did we discount? They can calculate efficiency variances. Did we complete the work in the expected number of hours, or did it take longer? They can calculate mix variances. Did we use the planned mix of partners, seniors and juniors, or did we use a different mix? All the same logic, just adapted to professional services instead of physical products. Or take a hospital. They budget nursing hours per patient day, medication costs per patient, overhead costs per occupied bed. Actual performance varies. They calculate spending variances on supplies, efficiency variances on labor utilization, volume variances based on patient census. They use that analysis to identify opportunities for cost reduction and quality improvement. Or take a university. They budget faculty salaries, administrative costs, facility expenses per student or per credit hour. They track actuals, flex their budgets to actual enrollment, calculate variances, and investigate deviations. The point is this: the principles of variance analysis are universal. Any organization that plans and measures can use them. The specific metrics and cost drivers differ by industry and context, but the logic remains constant. Here's a gem for you. Accounting adapts to serve business. Business doesn't adapt to fit accounting. Variance analysis is a framework, not a formula. You take the framework and customize it to your reality. That customization is where your judgment and creativity come in. Don't memorize the parka example and think that's all there is. Internalize the logic and apply it to whatever business you're managing or analyzing. That's what professionals do. Now let's bring this full circle and talk about how variance analysis connects to your development as a business leader. Variance analysis and business judgment, developing your craft. Variance analysis teaches you more than just cost accounting formulas. It teaches you how to diagnose business performance, how to ask the right questions, how to trace effects back to causes, how to separate signal from noise, how to create accountability without blame. and how to drive continuous improvement. These are foundational management skills that transfer across any function, any industry, any level of seniority. Let me break that down. First, diagnosis. When you practice variance analysis, you're training yourself to look at data systematically, to decompose problems into components, to isolate variables. That diagnostic mindset is essential for managers. Business is complex, full of interacting factors and ambiguous signals. The ability to cut through complexity and identify root causes is rare and valuable. Second, questioning. Variance analysis is fundamentally about asking why. Why did costs exceed budget? Why did efficiency decline? Why did prices change? That curiosity, that refusal to accept surface answers, that's what separates deep thinkers from shallow ones. You're building a habit of intellectual rigor. Third, accountability. Variance analysis forces clarity about who controls what. That clarity enables constructive performance conversations. You're not vaguely blaming the department for problems. You're having specific discussions with specific managers about specific variances. That precision makes feedback actionable. Fourth, improvement orientation. When you view variances not as failures but as learning opportunities, you create a culture where problems are surfaced and solved, rather than hidden and perpetuated. That mindset, that culture, that's what builds great organizations. As you master variance analysis, you're really mastering a way of thinking about performance. You're developing what Aristotle called phronesis, practical wisdom, the ability to discern what matters, to interpret context correctly, to make sound judgments. That's the ultimate goal here. Not memorizing formulas, not passing tests, but developing the judgment that makes you effective as a leader. And that judgment comes from practice, from doing accounting, from working through real problems, from making mistakes and learning from them. That's the why behind the why at the deepest level. We study variance analysis to become better thinkers and better leaders. Now let's talk about integrating variance analysis with other management tools for comprehensive performance management. Integration with balanced scorecard and KPIs. Variance analysis focuses primarily on financial performance, specifically on cost control and efficiency. But comprehensive performance management requires a broader view. That's where frameworks like the balanced scorecard come in. The balanced scorecard, developed by Kaplan and Norton, measures performance across 4 perspectives: financial, customer, internal processes, and learning and growth. Variance analysis contributes to the financial perspective and the internal processes perspective, but it needs to be complemented by measures in the other areas. For example, you might have favorable efficiency variances because you're pushing production speed, but if that speed comes at the cost of quality defects, customer satisfaction drops, and you haven't actually improved performance, you've just shifted problems from one area to another. Or you might have unfavorable labor cost variances because you're investing heavily in training. But if that training improves retention, capability, and innovation, the investment pays off in other ways that variance analysis doesn't capture directly. The point is integration. You need financial variances plus customer metrics like Net Promoter Score, plus process metrics like cycle time and defect rates, plus learning metrics like employee engagement and skills development. Companies like Google, Microsoft, and Samsung use integrated dashboards that combine variance analysis with broader KPIs. They don't look at cost variances in isolation. They look at cost variances in the context of quality, speed, innovation, and customer value. That holistic view prevents myopic decision-making. It keeps you focused on what really matters, creating value, serving customers, building competitive advantage. Variance analysis is part of that equation, an important part, but just a part. As you develop as a professional, cultivate that systems thinking. Understand how different metrics connect, how optimizing one thing can sub-optimize another, how true excellence requires balancing multiple objectives simultaneously. That perspective separates tactical managers from strategic leaders. Now let's talk about what you need to do to truly master this material. Mastery through practice. Your path forward. Let me be direct with you. You can listen to this lecture 10 times. You can read the textbook 5 times. You can highlight every concept and formula. But until you actually do variance analysis, work through problems, build flexible budgets, calculate variances, interpret results, you don't really know it. That's the central truth I want you to embrace. To know accounting, you must do accounting. This isn't passive knowledge you absorb. It's active skill you develop through practice. Here's what I recommend. First, work through the practice problems systematically. Don't just look at the solutions. Work them out yourself, make mistakes, figure out where you went wrong. Try again. That struggle is where learning happens. Second, find real financial data from public companies, their annual reports, their cost structure disclosures, and practice building flexible budgets and estimating what their variances might be. That connection to real business makes the concepts concrete. Third, if you work in any organization, try applying variance analysis informally to things you can observe: your department budget, your personal budget, anything with planned versus actual performance. The more context you practice in, the deeper your understanding becomes. Fourth, teach someone else these concepts. Explaining flexible budgets to a classmate or a family member forces you to clarify your own thinking. If you can't explain it simply, you don't understand it deeply enough. Fifth, reflect on the why behind the why. Don't just memorize that labor efficiency variance equals standard rate, times the difference between actual and standard hours. Understand why we separate rate and efficiency, why we use standard rate in the efficiency formula, what managerial insights that separation provides. That depth of understanding transforms mechanical calculation into professional judgment. Here's the gem I'll leave you with. Excellence in any field comes from deliberate practice, not just doing the work, but doing it with intention, focus, and reflection. Basketball players don't become great by playing pickup games casually. They become great by drilling fundamentals, by practicing specific moves thousands of times, by studying film, by getting coaching. Same principle applies to accounting and business. You won't master variance analysis by accident. You'll master it by deliberately working problems, by seeking feedback, by pushing yourself beyond comfort. That's the work, and that work pays off for your entire career. Now let's wrap up with how all of this connects to your professional future. Closing, the professional advantage. We've covered a lot today. Planning budgets versus flexible budgets, the importance of adjusting for actual activity levels, revenue and spending variances, isolating different dimensions of performance, multiple cost drivers, adding sophistication when needed, standard costs, setting benchmarks for materials, labor and overhead, price and quantity variances for materials, rate and efficiency variances for labor, rate and efficiency variances for overhead, responsibility assignment, linking variances to managers without creating dysfunction, integrated analysis, seeing patterns across multiple variances, and finally, how variance analysis fits into broader management systems. But beyond the technical content, I want you to understand the strategic value of what you've learned. Variance analysis is standard practice at sophisticated companies. When you interview for finance roles, operations roles, analyst positions, consulting jobs, they expect you to understand variance analysis. It's not optional, it's foundational. And the candidates who can not only calculate variances but also interpret them, explain them, and propose actions based on them, those candidates stand out. You're building a professional advantage. More broadly, you're learning how to think like a manager, how to look at data and see stories, how to ask questions that get to root causes, how to create accountability constructively, how to drive improvement systematically. These skills compound over time. In 5 years, you won't remember the specific formula for labor efficiency variance, but you will have internalized the logic of isolating performance dimensions, and that logic will serve you in every business situation you face. That's the deeper gift of studying this material thoroughly. I'll close with this. The numbers tell a story, and our job as accountants, as managers, as business professionals, is to read that story accurately and respond intelligently. Variance analysis is one of the most powerful tools we have for reading the story of performance. Master it, use it, let it make you better at understanding and improving business operations. That's the path from knowledge to wisdom, from accounting to leadership. Keep doing the work, keep asking the why behind the why, and keep elevating your understanding. I believe in your ability to excel at this, and I'm here to support that journey. Now go practice, go apply, go master this material. That's where the real learning happens. See you next class.